Hi everyone, I'm so excited to begin our first unit of precalculus together. The first unit is trigonometric functions, and the first topic in trigonometric functions is the unit circle. In this video, I will be going over the unit circle with you guys. So here's a picture of the unit circle, and in this video, I will be showing you what it is, how to use it, and how it applies to precalculus. So there are two systems on the unit circle. There are degrees and radians. There are 4 quadrants for degrees and for radians, and 4 quadrants in general in the unit circle. The degrees, starting from 0, go up by 30, then 15, 15, and then 30. And that repeats for each quadrant in the unit circle, so that repeats 4 times. Radians is also 4 sections because there are 4 quadrants in the unit circle, and radians are in terms of the fractions of 1/6, 1/4, and 1/3, except it's not 1, it's going to be pi because radians. And this starts from the horizontal x-axis to the vertical y-axis, which I will show you on the next slide. So, starting from 0, in the first quadrant, the degrees goes up by 30, then by 15, then by 15, and then again by 30. The second quadrant goes up by 30, then by 15, and then by 15 again, and then by 30. And this repeats for the third quadrant and the fourth quadrant. And then for radians, so it's the stuff with pi, because we know that pi correlates with radians. So it goes from pi over 6 to pi over 4 to pi over 3. And that repeats again. It goes from pi over 3, then pi over 4, then pi over 6. And that repeats for the third quadrant and the fourth quadrant. And the numbers on top, so the 2 pi, the 3 pi, the 5 pi, 7 pi, 5 pi, 4 pi, this is just stuff you have to memorize. So the unit circle is purely memorization. You need to memorize this in order to learn all the other lessons in pre-calc. It is crucial that you know this because we will be using the unit circle for almost every single lesson in pre-calc. The unit circle. So the regular graph coordinates that you already know that you learned in Algebra 2 and previous math courses is x, y. However, on the unit circle, those coordinates are cosine, sine. So x is cosine and y is sine. And I'll be showing you these positive and negative values of the quadrants on the next slide. So, in quadrant 1, cosine is positive and sine is positive. However, in quadrant 2, cosine is negative and sine is positive. Quadrant 3, cosine and sine are both negative. And in quadrant 4, cosine is positive and sine is negative. And this is permanent. This doesn't change because nothing on the unit circle ever changes. This is why it is so important to memorize it because it is the same thing repetitive for every single lesson that you learn. So each revolution on the unit circle is 2 pi. It starts from 0 and goes to 2 pi. So if somebody asks you to do 5 revolutions of the unit circle, you would do 5 times 2 pi, so it would be 10 pi. Somebody asked you to do 20 revolutions on the unit circle, it would be 20 times 2 pi, so it would be 40 pi total. Okay, so as I went over before, x is cosine on the unit circle and y is sine on the unit circle. So I will show you how to get the values of tangent, cosecant, secant, and cotangent. So we know that tangent is sine over cosine, right? And I already taught you guys that sine is y and cosine is x. So that's why it's y over x. And for cosecant, we know cosecant is 1 over sine, which is why sine is 1 over y. So that's why cosecant is 1 over y. Secant, we know is 1 over cosine. We know in the unit circle cosine is x, so this is 1 over x. And then for cotangent, we know cotangent is equal to cosine over sine. And on the unit circle, we know cosine is x and sine is y. And that is how you get these 4 equations. So all these 4 equations is how you would solve for these 4 things on the unit circle when you have to determine what the values of a certain specific tangent or a certain cosecant is on the unit circle. You would use these equations based on the coordinates. Okay, so now let's move on. Let's move on to some unit circle problems. So Here are some problems: sine of pi over 6, cosine of pi over 3, tangent of pi over 2. So I'm going to write them at the bottom of the screen so we can go over them in the next slide. So we have sine of pi over 6, we have cosine of pi over 4, we have cosine of pi over 3, we have the sine of pi, we have the tangent of pi over 2, and we have the cosine of 11 pi over 6. Okay, let's go to the next screen and do these problems. So, let's find the sine of pi over 6. So, pi over 6 is right here. We know that sine is equal to the y value, which is right here. Y sine of pi over 6 would be 1/2. Let's go and find pi over 3, which is right here. So, cosine of pi over 3 would be the x value, so it's also 1/2. Let's find pi over 2. Tangent of pi over 2. We went over that tangent is y over x, sine over cosine. So it would be 1 over 0 for tangent. However, we know that you can't divide by 0, which is why this would be undefined. Okay, let's move on to cosine of pi over 4. Pi over 4 is right here. Cosine is the x value. So it's root 2 over 2 is cosine of pi over 4. Sine of pi is next. So pi is right here. We know that sine is the y value, so sine of pi is 0. Lastly, for this set of questions, we know that 11 pi over 6 is right here in the unit circle. We know that cosine is the x value. The x value is root 3 over 2, which is why cosine of 11 pi over 6 is equal to root 3 over 2. Now let's move on to the next set of problems. So these problems are going to be getting a little bit harder, but it's okay, we will work through it together. So, first the secant of 2 pi over 3. So let's go back and find 2 pi over 3 on the unit circle and then continue from there. So 2 pi over 3 is right here. We know that secant is 1 over cosine. Cosine here is negative 1/2. So, let's do that together. 1 divided by negative 1/2 is the same as 1 times negative 2, because when you divide by a fraction, you multiply by the reciprocal. So the secant of 2 pi over 3 is negative 2. And let's check that on the screen next. We are right. The answer is negative 2. Cotangent of 3 pi over 4. So, we know on the unit circle, cotangent is x over y. The coordinates at 3 pi over 4 in the unit circle are negative root 2 over 2 and root 2 over 2. So, the work for this would be x divided by y, which is what I have here. Negative root 2 divided by root 2 over 2, and if you do the work for this, you will get negative 1. And I will show you up above the work for this. So, we know that negative root 2 over 2 divided by root 2 over 2 is the same as multiplying by the reciprocal. So, times root 2 over 2. We can do cross multiplication. We can cancel these, and we are left with a negative 1. Let's move on. Cosecant of 7 pi over 6. We know on the unit circle, cosecant is 1 over y. We know that at 7 pi over 6, the y value is 1/2. So, we do 1 divided by 1/2. However, we can just do 1 times the reciprocal, and the reciprocal of 1/2 is negative 2. 1 times negative 2 is equal to negative 2, which is why the answer is negative 2 for cosecant of 7 pi over 6. Next, let's do the tangent of negative 5 pi over 6. So this might look a little different to you, but we know that the whole unit circle is 2 pi, right? So we can equal this to be a fraction over 6. So we know that 12 divided by 6 is 2. So we can get it to equal to 12 pi, right? So 12 pi over 6 divided by minus 5, or subtracting 5 pi over 6 from 12 pi over 6 is 7 pi over 6. And we know that 7 pi over 6 is on the unit circle. So let's go back and show that. So 7 pi over 6 on the unit circle. I will show you that. I will show that to you guys. 7 pi over 6 on the unit circle is right here. And we want to do the tangent of it. So here are the coordinates for 7 pi over 6. So let's go to the next slide. So the tangent of 7 pi over 6. We know that the x value is -1/2 and the y value is root 3, or we know that the y value is 1/2 and the x value is root 3 over 2. So in order to solve for tangent, we do y over x. So I will show you here the work for this. We know that the y value for 5 pi over 6 is -1/2, so -1/2. Then we know that the x value for 7 pi over 6 is root 3 over 2, which is the same as multiplying by -2 over root 3. So if we do this work, 2 cancels out, and the negatives also cancel out. So we get 1 over root 3. However, we don't like having square roots in the denominator. So we multiply by root 3 again over root 3. And we get root 3, because 1 times root 3 is over 3. And root 3 times root 3, the roots cancel here, and you get root 3 over 3. Now, we do not have a square root in the denominator, so this is good. Okay, let's do the next problem now. So, cosecant of -4 pi over 3. So, I will show you the work of how to get -4 pi over 3 on the unit circle. We know that there are 2 revolutions. 2 pi is 1 revolution on the unit circle. So, we need to get this in terms of a fraction of 3. We know that 6 divided by 3 is 2. So 6 pi over 3 would be 2, which is why it would be 2 pi. Then 6 pi over 3 minus 4 pi over 3 is equal to 2 pi over 3. Now this should be familiar to you, because 2 pi over 3 is on the unit circle. So let's go back to the slide before and find 2 pi over 3 together on the unit circle. 2 pi over 3 is right here. The cosine value is -1/2 and the sine is root 3 over 2. Now let's solve. So cosecant for 2 pi over 3. We know that cosecant is 1 over y. And we know that on the unit circle, the y value for 2 pi over 3 is root 3 over 2. So we have to do 1 divided by root 3 over 2. However, it's the same as multiplying by the reciprocal. So you would do 1 times 2 over root 3, and you would get 2 over root 3. However, we do not like having square in the denominator, so you do the same thing and you multiply again by root 3 over 3, and this time you get 2 over root 3 over 3 because the roots cancel out here. So here's our answer for the cosecant of -4 pi over 3. Let's move on to the last question on this screen. The cosine of 31 pi over 6. So, this looks like a big number and looks tricky. However, it really is not. So, we know, again, that on the unit circle, there are 2 pi, which is 1 revolution. So, in terms of a fraction of 6, this would be 12, right? Because 12 divided by 6 is 2, so 12 pi. So, we just have to subtract 31 pi over 6. We have to subtract 12 pi a few times until we get a familiar value that's on the unit circle. So if we subtract it once, minus 12 pi over 6, we are not going to get a familiar value. However, if we subtract it twice, it would end up being 31 minus 24, which is 7 pi over 6. 7 pi over 6 should stick out to you because it is a value that is on the unit circle. So let's go back, and I will show you how 7 pi over 6 is on the unit circle, which we already went over in this video, actually. So 7 pi over 6 is right here, negative root 3 over 2, and then negative 1/2. Okay, so now let's solve. So for the 7 pi over 6, we need to do the cosine of it. This is such an easy problem because we know that the x value at 7 pi over 6 is negative root 3 over 2. So the cosine of 31 pi over 6 would be negative root 3 over 2. Here are some more unit circle problems that you have to provide both degree and radian answers for. And these problems are a bit different, okay? So these are not involving what we did on the last screen. This is a new set where you have to identify the coordinate first. So it gives you the coordinate, and you have to identify it in terms of degrees and radians. So it says the sine of theta is root 2 over 2. And we have to solve theta for degrees and for radians. So let's go back to the unit circle and let's find root 2 over 2. Root 2 over 2, positive root 2 over 2 is right here. Okay, so it was sine. So sine is the y value. So right here, sine of root 2 over 2. In degrees, it's 45 degrees, and in radians, it's pi over 4. Also on the unit circle, sine of root 2 over 2 is at 3 pi over 4. It's positive here. So the radians would be 3 pi over 4, and the degrees would be 135 degrees. Okay. Now, the secant of theta. So we have to determine the secant of theta. So where the secant of theta is undefined on the unit circle, we know that for something to be undefined, it has to be 1 over 0, right? And we know that secant is 1 over cosine, meaning that we have to find a spot on the unit circle where the cosine has to be equal to 0. So let's go back to the unit circle and find where cosine is 0. Cosine is 0 at pi over 2 and at 3 pi over 2. See, the cosine here is the x value. So at pi over 2, it's 0. And at 90 degrees, it's 0. So the answer of the secant, where it's undefined, would be pi over 2 and 90 degrees. Cosine is also 0 at 3 pi over 2 and 270 degrees. So these would also, a cosine of these values would also get you an undefined answer. A secant of these values would get you an undefined answer. The cosine is the 0, which would lead to it being 1 over cosine, which would be 1 over 0, which would get you an undefined value because 0 is in the denominator. Okay, next, let's find tangent of what value is equal to 0 on the unit circle. So we know that for this to happen, we have to get a value in terms of sine and cosine that equals 0. And it has to be able to be defined. So we know that if we do 0 divided by 1, that will get you a good value of tangent, right? So tangent is equal to sine over cosine, meaning the sine has to be 0 in order for the cosine not to be 0. So let's go back to the unit circle. So the tangent of theta is equal to 0. So we are looking for, I will write this out for you. So we are looking for tangent is equal to sine over cosine, right? And we need this to equal a number over a number to equal to 0, okay? We know that 0 can't be in the denominator. So we know that the sine is going to have to be 0 and the cosine is going to be 1. So where the sine is 0 in the unit circle is at 0 radians and 0 degrees. We also know on unit circle 0 sine is at pi and 180 degrees, right? 0, negative 1. We know that 0 over negative 1 is equal to 0. So the tangent of these 4 values right here, so 1, 2, 3, 4, would get you 0 on the unit circle. Okay, let's do the next problems now together. So, where we have to find the cosine of theta is equal to negative 1/2. Okay, so this is a simple problem. Let's go to the unit circle. Let's find negative 1/2 as the x value. So the x value right here, negative 1/2. Negative 1/2 cosine. That's at 2 pi over 3 and 120 degrees. We also know that the cosine is equal to negative 1/2 right here, which is at 4 pi over 3 and at 240 degrees. So those would be your answers, the ones that are circled. Okay, we have 2 more questions now. The cotangent of negative root 3. Okay, now let us think about this. So, cotangent. We know that cotangent is equal to cosine over sine. We need cosine over sine to equal negative root 3. Okay? So we need to come up with values for cosine and sine that would get you negative root 3. Okay? So let's go to the unit circle and negative root, well actually let's go over right here right now, cosine and sine on the unit circle. So we know it has to equal negative root 3. So this seems tricky, but if you know the unit circle really well, which you will after you memorize it, this is not that bad of a problem to solve. Okay, let's solve for cosine and sine to be negative root 3. So we know that we're going to need a 2 to cancel out somewhere. So if we put cosine as root 3 over 2, and we put sine as negative 1/2 in order to get this negative right here, so we would multiply by the reciprocal of negative 1/2, which is times negative 2 over 1. This would cancel out the 2's and would get you negative root 3. So we just established that cosine needs to be root 3 over 2, and sine needs to be negative 1/2. So on the unit circle, let's find where there is a positive root 3 over 2 and a negative 1/2. When you look at the unit circle, you will find that it's 5 pi over 6 at 150 degrees and 11 pi over 6 at 330 degrees. Okay, lastly, let's do the last problem of this lesson. Cosecant of theta is equal to negative 2 root 3 over 3. We know that cosecant is equal to 1 over, I have to put the drawing on. We know that cosecant is 1 over sine. So we need this to equal negative 2 root 3 over 3. So we know this looks familiar, right? So 1 over sine. 1 over sine. We have to get this 1 over, and it has to be negative, right? So negative root 3 over 2. Right? So if we multiply by 2, that gets rid of the denominator, the fraction of the denominator, so we would get 2 over negative root 3. However, we cannot have a root in the denominator, so we multiply by root 3 over 3. Root 3 over 3. And we would get negative 2 root 3 over 3. So we just figured out that we need sine to be negative root 3 over 2. If you look on the unit circle, you will find that 5 pi over 3 and 300 degrees gives you negative root 3 over 2 as the sine value, so the y value, and at 4 pi over 3 at 240 degrees, that also gives you the sine value of a negative root 3 over 2. And that concludes this video. Please like, subscribe, hit the post notification bell, drop a comment down below, and share using our socials. You can email us at eCoreAcademy@gmail.com and visit our website for more features. Thank you so much for watching this video, and I hope to see you in the next one. Thanks!